This is the third type of question, and I just have two examples to show you here, but there are so many more examples that I can include. It's just, this is getting a little bit long. So the third type of question is when you're given the input and output, and the question is not to find the mass of the product or the amount of time that it would take to get a certain amount of product, but to use information regarding input and output to identify the substance. So this is example 6. In an electrolysis experiment, a current of 4.50 amps, so the current is 4.50, was supplied for 7 minutes. So time is 7 minutes, or I actually cannot do maths this morning, 422 seconds, to an electrolytic cell consisting of inert electrodes. Electrodes are inert, and you have a solution of 1.0 molar MnO32 for aming an unknown metal. So you don't know what am is. So am is not the actual symbol of the element. It's like X in an equation. It's just an unknown. 2.03 grams of metal. So mass of M, we really should have used another letter, is 2.03 grams. And you need to work out what M is. Okay, a few things here. The only way to determine the identity of an element is via its molar mass. So if I want to know the identity of M, I need to find, oh, this is unfortunate, I need to find the molar mass of M, which is M of M. That's why I said it was unfortunate. If I can work out the molar mass of M, I can check using the periodic table to work out what M is. So if the question asks you to determine the identity of an element, you want to find the molar mass of that element. That's pretty much the only way to determine the identity of an element, I think. So think about what information you actually need to find the molar mass of something. Molar mass, and this question is interesting and potentially difficult because people normally don't have to find molar mass. That's like the one thing that's given to you in the periodic table. So if I ask you how to find the molar mass of something, it can be quite hard for people to imagine. But molar mass is just mass over number of mole. So if you just rearrange the equation that you normally use, I already have the mass of M. The mass of M is 2.03 grams. So if I could determine the number of mole of M, I can find the molar mass of M, and then I can find the identity of M. In order to determine the number of mole of M, you need to have an equation that links M with something else. So you could potentially use mole ratio, because I don't think there's anything else that you could do here. And because this is an electroplating experiment, because they tell you, is it electroplating? Oh yeah, they say the metal was plated. You know M is the product of the reaction at the cathode, and if you look at this formula of the electrolyte, it tells you that the charge of the ion of M must be 2 plus. So I know the equation must be M2 plus 2 electrons going to M. So this will allow me to establish a relationship between the number of mole of M and the number of mole of electrons, which is a 1:2 ratio. So if I can find the number of mole of electrons, I can find the number of mole of M, and then I can find the molar mass. All right, let's do that. So in order to find the number of mole of electrons, you need to use the charge. So I need to find the charge, 4.5 times 420 seconds. Let's do that. 4.5 times, so 1,890 coulombs. And then number of mole of electrons given this charge is the same as 1 mole of electrons given 96,500 coulombs. So number of mole of electron is 1890 over 96,500. Okay, 96500. 0.0196 mole is the number of mole of electrons. So the number of mole of M, if we use the mole ratio that we established earlier, is going to be half the number of mole of electrons, which is half times 0.0196. Okay, so divided by 2, so we have 0.00979 mole. Okay, so now I can find the molar mass. I'm not going to write m of m, it looks a bit strange. So molar mass of m is mass of m divided by number of mole of m, which is 2.03, I believe it was. Yep, 2.03. Moment of truth. Because if I've done something wrong, it will come out with a molar mass that doesn't fit any element. So, you know, fingers crossed here. But that's all right. We make a mistake, we just go back and check it. So I get 207.3. That's good. 207.29. That's PB, isn't it? Grams per mole. It's the unit. Oh, extra points for anyone who remember the unit of molar mass. So PB in the periodic table is 207.2, but I think that's close enough. So M is PB. No sig fig is an identity. Okay, that's example 6. Moving on to example 7, it's very, very similar to 6, except for one thing. So you're not finding the identity of the metal, you're finding the charge of the metal ion. And you're not going to be able to just look at the periodic electrochemical series, because a metal, a transition metal, and gold in this case, a transition metal, can have more than one charge. So the one listed on the electrochemical series may not be the one that you need. In an experiment to determine the charge of gold ions, an aqueous solution of a salt of gold was electrolyzed. When the electrolysis was performed using a current of 7 amps, so you have the current, for 158 seconds, so 158, you're given the mass of gold, 0.750 grams. You have to find the charge of gold ion. So there are 2 different charges of gold ion that I know of, but there could be more than 2. So if you don't know what the charge is, but you know that this is supposed to be electroplating, because they tell you that the gold is deposited. So the gold is going to be the product of this equation. But I don't know what the reactant is. Well, I know the reactant is an ion of gold, but I don't know what the charge is. So we can call it X plus. Could be 1 plus, 2 plus, 3 plus. And then if you need X amount of electrons to get to here. So what I'm trying to say here is that the number of mole of electrons, the ratio between the number of mole of electrons and the number of mole of the gold, is going to give you an indication of what the charge is. So if the ratio is 1 to 1, it means that the charge of the ion was 1. If the ratio is 2 to 1, the charge of the ion will be 2, and so on. So if I can find this ratio, I can find the charge of the ion. So we need to find N of electrons and we need to find N of gold, which I think we can do both quite easily. The number of mole of electrons, so we're going to find the number of mole of electrons, and this is very easy. We've done so many of these in the past. Well, I've done so many of these in the past half an hour, because you're given current and time, so you know one short-term memory loss, 7 times 158. So 7 times 158 is 1106 coulomb, and then from here I can find the number of mole of electrons. For 1106 coulomb is 1 mole of electrons over 96,500 coulombs. So 1106 times 1 over 96,500 is 0.00115 mole. So that's the number of mole of electrons. The second thing that you need is the number of mole of gold, and you should be able to find this because you're given the mass of gold and you know that it is gold, so you know what the molar mass is. So the mass of gold was 0.75. I literally just looked up the molar mass of gold and I forgot it already. 197, I think. Yep. So 0.75 divided by 197 is 0.003807 mole. You really want to keep the exact values for both the number of mole of gold and the number of mole of electrons, so that your ratio is going to be as accurate as possible. But I will go 0.00115 over 0.003807 think I've done something wrong. Oh, yeah, yeah. Just a transfer error. That's supposed to be 0.0115. So only 1 0. Whew. Anyway. See, everyone makes mistake. As long as you pick it up before the time ends, before you finish the question. So you're going to get a ratio of very close to 3, and that's saying that the charge of the gold ion is 3, or is Au 3 plus, or charge is 3 plus. Not positive 3, 3 positive. There's a difference between charge and oxidation number. That's it.